Welcome back to the deep dive. Today, we are leaving the lobby.
Mm.
We are ignoring the penthouse. We are going straight down to the basement.
Right down to the engine room.
I want you to picture it.
Mm-hmm.
The hum of industrial ventilation, the smell of hot motor oil, maybe a little bit of ozone.
The part of the hotel that the guests absolutely never see, but without which, the entire operation grinds to a halt in about 4 hours.
Exactly. We're looking at a document today titled The Architecture of Enduring Hotel Conveyor Systems. And look, I'm going to be honest right up front. It sounds incredibly niche.
It does.
We're talking about those spinning metal racks that deliver uniforms to the maids and the chefs.
It sounds niche, but it's actually, I think, a Trojan horse.
A Trojan horse. How so?
Yes. Because inside this discussion about, laundry conveyors is probably one of the most important lessons on technology procurement, right to repair, and the economics of longevity that I've seen in a long time.
So this isn't really about laundry.
No, it's about a trap that almost every modern business, and honestly every consumer, falls into.
That is a big claim. So we're talking about a technical trap.
We are, and it's a trap that costs companies hundreds of thousands of dollars, or in this specific case, hundreds of thousands of Singapore dollars.
Okay, so let's set the stage before we get to the money. What exactly are we looking at here? Because when I think of a conveyor, I just think of, a luggage belt at the airport.
Yeah, a simple loop.
Just a rubber strip moving in a circle.
This is a bit more complex. These are automated uniform distribution systems. Imagine a dry cleaner's setup, those metal rails that snake around the ceiling, but on a massive industrial scale.
Okay.
You have hundreds of staff members, housekeeping, kitchen staff, front desk. They all need clean uniforms daily.
And doing that by hand would be a nightmare, I'm guessing.
Oh, it's slow. It requires staff to man a counter. Uniforms get lost. So hotels install these robots. You walk up, swipe your ID badge, the system reads your profile, and this massive rack spins around and drops your specific uniform at a collection door.
It sounds efficient. Sleek.
It is.
Okay, so where is the problem? That sounds like a standard automation win. You buy the machine, it does the work.
The problem isn't the machine. The problem is the architecture of the purchase.
Ah.
The source identifies a critical flaw in how these systems are currently sold. It's the tight, inseparable binding of three things: the physical hardware, the steel and motors,
Right.
the RFID tracking, so the sensors, and the software, the brain.
But isn't that just how tech works?
Mm-hmm.
I mean, I buy an iPhone, I get the iOS, the Face ID sensor, and the phone itself. They're all one unit.
And that is exactly the comparison we should be making. But think about the lifespan. You replace your phone every, 3, maybe 4 years?
If I'm lucky, yeah.
A hotel conveyor system is built out of heavy-gauge steel. It has industrial motors, heavy chains, solid bearings. Mechanically, that thing is built to last 20, maybe 30 years. It's infrastructure.
Okay, I see where you're going.
But the software is fragile.
Fragile how?
Well, software rots. Not literally, but functionally. The vendor goes out of business. The operating system it runs on, say, an old version of Windows Server, stops getting security updates. Or the database format becomes obsolete.
Right.
And if that software is tightly integrated, meaning the hardware literally cannot move without a handshake from that specific proprietary code, you have a massive problem.
So let's say 5 years in, the software just glitches out.
Yeah.
Or the company that sold it to you gets bought out and shuts down their server.
Then your 20-year piece of steel becomes a 20-ton paperweight.
You can't just fix it. I mean, surely you can get an IT guy to go in there and, patch the code.
That's where the traps snap shut. Usually these systems use proprietary protocols. The language the computer uses to talk to the motor controller isn't standard. It's encrypted or it's just obscure.
So you can't get under the hood.
You can't just hire a hacker to fix it because they don't have the keys. The source is very blunt about this. It says, when the software fails, you don't just replace the software. You replace the entire system.
That is insane. That's like having to crush your car because the Bluetooth radio stopped working.
It is exactly like that. And we see this everywhere, right? Look at the right to repair fight with John Deere tractors. Farmers can't fix their own engines because of software locks. This is just the hotel version of that.
So you have a perfectly good mechanical asset that is held hostage by a digital liability.
Held hostage is a great way to put it. You've got the durable, the steel chain to the ephemeral, the code, and the ephemeral part kills the durable part.
It's an architecture failure.
Precisely. You're prioritizing integration over longevity. And look, I get why buyers do it. It feels safer to buy the all-in-one package. Ideally, it just works.
But the source argues that it just works is a temporary state. It just works until it doesn't, and then it costs a fortune.
Which brings us to the economics. Because the only reason these systems exist in the first place is to save money.
Right. The source gets into the P&L, the profit and loss. It mentions a specific figure, SGD 30,000 per year, for one uniform issuing staff member.
All right, so about 23,000 US dollars. And that's probably a conservative estimate.
Oh, for sure.
If you factor in recruitment, training, benefits, and just the fact that finding people willing to sit in a basement handing out shirts is getting harder, the real cost is likely much higher.
Okay, so the math on the napkin looks good at first. You buy the robot for, let's say, the cost of 3 years of wages.
Yeah.
After year 3, it's pure profit. You're saving that 30 grand every single year.
That's the pitch. That is what gets the budget approved. But now let's layer the technical trap on top of that spreadsheet.
I see where you're going. If the software bricks the entire system in year 5,
If you have to rip out the whole steel structure in year 5 because the software vendor went under or a license expired or, I don't know, a hardware controller is no longer compatible with a forced software update,
you've wiped out all your savings.
you're actually in the red.
Yeah.
You paid for the machine, saved a bit on labor, but now you have a massive capital expenditure, a CapEx hit to buy a whole new machine. Exactly. The total cost of ownership, the TCO just skyrockets. The savings were an illusion because they depended on the system lasting 15 years, but the software killed it at 5.
It seems so obvious when you lay it out like that. But I imagine in the heat of a big construction project, nobody's asking, hey, what happens to this specific server in 2032?
No, they're asking, does it integrate with our property management system right now? They're maximizing for today's convenience, not tomorrow's resilience.
But here's the twist in the source material that really caught my eye.
Mm-hmm.
We've established the trap, but then the source says, quote, today the rules have changed. And the reason they've changed is our favorite buzzword,
Artificial intelligence.
AI.
This is the part that I think is going to blow some minds, because usually when we talk about AI and automation, we think, oh, the AI will make the robot smarter. It'll predict which shirt you want.
Right, predictive analytics. That's the usual pitch.
But the source argues the exact opposite. It says the value AI here isn't to make the system smarter. It's to make the software cheaper and replaceable.
Okay, unpack that for me, because I still think of software as this expensive, magical thing that only, wizards in Silicon Valley can create.
That was true 10, maybe even 5 years ago. Writing a custom driver, a piece of code that tells a specific motor to spin at a specific speed, that was a specialist job.
Right.
You needed a systems integrator, weeks of testing. It was expensive, and that's why vendors locked it down. They were protecting their investment. Code is gold.
And now?
Now, you can take the manual for a frequency inverter, the motor controller, feed it into a large language model and say, write me a Python script to control this motor via Modbus protocol. And the AI just spits it out in seconds.
So the moat that these software companies build,
Yeah.
the idea that only we can make this machine talk, it's drying up.
It's evaporating. The scarcity has completely shifted.
Right.
Software used to be the scarce resource. Now, software is abundant. Code is everywhere. It's fast to write, fast to test, easy to replicate.
So if software is abundant, what's the scarce thing?
The hardware, the atoms, the steel, the copper, the installation labor, the permits, the logistics of getting a 2-ton machine into a hotel basement. That is the hard part. That is the expensive part.
That is a massive flip in the value proposition. We've spent 20 years being told hardware is a commodity and software is where the value is.
Mm.
And this source is saying, no, in the age of AI, the steel is the gold and the software is just the wrapper.
It's the wrapper paper. And you don't keep the diamond locked inside the wrapper paper if the paper starts to rot. You throw the paper away and you wrap it in something new.
So, practically speaking, how does this change what I should buy? If I'm that hotel manager, does that mean I should just buy a bunch of motors and build it myself?
No, you don't want to be a DIY mechanic, but it changes what you demand from the vendor. This brings us to what the source calls the correct logic.
Okay.
It's all about decoupling.
Decoupling, separating the brain from the body.
Completely. You want to buy a conveyor system that is, for lack of a better word, dumb.
Dumb is usually an insult in tech.
In infrastructure, dumb is a compliment. Dumb means robust. You want a system where the motors, the sensors, the controllers, they all speak a standard open language, something like standard industrial PLC logic, not some encrypted proprietary black box.
Okay, I'm going to play devil's advocate. I'm the buyer. I'm busy. If I buy the dumb system, doesn't that just mean I have to be the one to figure out how to make it smart? Doesn't decoupling just mean more work for me?
That is the friction point, and that's a fair question. Yes, the integrated system is easier on day one,
Right.
but the decoupled system is infinitely easier on day 2000, and you don't have to do the work yourself. You just need to ensure the capability is there.
So how do I check for that? I'm sitting across from a slick salesperson. They've got a PowerPoint deck full of synergy and cloud integration. How do I cut through that?
The source proposes a really simple test. I call it the 5-year test. You just look them in the eye and you ask, 5 years from now, if your company disappears or if I cancel your software subscription, can this conveyor still operate?
And if they say, well, it needs to ping our server to verify the license, or the controller only works with our app.
Then you walk away. Because you aren't buying a machine, you're renting a liability. You are buying a trap.
I can just imagine the sales reps sweating when they hear that question,
Of course.
because their whole business model is often built on that recurring revenue, that lock-in.
They want to be the subscription you can't cancel. But as a buyer, your leverage is in that initial purchase. You have to demand, give me the API documentation, give me the local control protocols. If they refuse, it's because they know their software is the only leash they have on you.
And with the AI angle we discussed, if the hardware is open, if it speaks a standard language, even if the original software is terrible, you could theoretically just swap it out later.
Exactly. Let's say the interface is clunky. In the old world, you're just stuck with it. In the new world, where the hardware is open, you could hire a local developer or, use an AI agent to build a new, better interface that talks to the same old reliable steel. You keep the asset, you upgrade the experience.
That is true sustainability. We talk a lot about green tech, but usually that just means uses less electricity. This is about doesn't end up in a landfill.
Hotel BOH systems are not about features, the source says. They are about what still works after 10 years. And that really sums it up. A shiny dashboard is nice. A working machine is essential.
It's funny, we started this talking about hotel laundry, but my brain is jumping to everything else I own. My smart fridge, my car, my thermostat.
It applies to all of it.
I have a set of smart light bulbs at home. I won't name the brand,
Yeah.
but they connect to a central hub. If that company turns off their server, I literally cannot turn on my lights.
Oh, wow.
I have to unscrew them and throw them in the trash.
That is the technical trap in your living room. You bought glass and LEDs, durable hardware, that is artificially killed by software.
And the source's argument is that we need to stop accepting this. We need to value the dumb functionality. A light switch that works without Wi-Fi is actually a superior piece of engineering to one that requires the cloud.
It is. Resilience is a feature. In fact, for critical systems, and I'd argue a hotel's laundry flow is critical resilience, is the primary feature.
So let's wrap this up, sort of package it for the listener. We've covered a lot of ground.
We have. We started with the trap binding software, RFID, and hardware into a knot that you can't untie.
Which leads to catastrophic financial loss when the software inevitably ages out before the hardware does. That SGD 30,000 annual saving just evaporates.
Then we looked at the paradigm shift. AI has made code abundant and cheap, and this inverts the whole value pyramid. Hardware is now the scarce, valuable asset.
Which leads to the correct logic, decoupling, making sure that the expensive steel isn't subservient to the cheap code.
And the 5-year test. Always ask if the machine can survive the death of its creator.
It's a powerful way to look at the world. It's almost philosophical. We're moving from a world of products to a world of
What?
components.
Maybe capabilities.
Yeah.
You're buying the capability to move uniforms. How you control that capability should be fluid. It should change over time. The steel stays, the mind changes.
That reminds me of the ship of Theseus paradox, but like in reverse. The body stays the same, but the soul keeps getting swapped out.
That's a great way to put it.
I want to leave the listener with one final, slightly provocative thought that came to me reading this. We talked about AI writing code, and we talked about how software is becoming disposable.
Right, the paper cup analogy.
But take it a step further. If AI keeps getting faster and better, are we heading toward a future where software versions don't even exist?
What do you mean by that?
Imagine a conveyor system where every time you turn it on, an AI analyzes the hardware, it analyzes what you need to do that day, and it writes a custom operating system just for that shift.
Wow.
Real-time, ephemeral code. It exists for 8 hours, does the job perfectly, and then just deletes itself.
That is both brilliant and terrifying.
In that world, the whole idea of proprietary software lock-in becomes laughable. It would be like trying to copyright a conversation. The code is just a ghost that passes through the machine.
And in that world, the only thing that matters, the only thing you can truly own, is the machine itself. The steel, the motors, the reality.
So next time you're buying something smart, whether it's a factory robot or a toaster, ask yourself, am I buying a tool I own, or am I buying a subscription to a ghost?
Make sure you own the tool.
Words to live by. Thanks for going down to the basement with us today.
It was a pleasure.
See you on the next deep dive.